Hello guys, welcome back to another video. This first storm I'm going to show you, this SPC map, is from the Moore tornado in 2013. It was a pretty dangerous tornado. I think 20 people were killed in it. This is just the day 1 categorical outlook. I'm going to show you what a typical day looks like for tornado activity. This is a pretty crazy one. This is when the moderate pops up. That's usually a good indicator. 10% of significant tornadoes is also another indicator. Anything with the significant tornadoes usually means a lot higher of a chance than it actually is. And then damaging winds, same thing. If there's damaging winds in the forecast too. And hail, that's usually when you know there's a lot coming that way. And then hail. And then it says several strong way possible. There's quite a few. This thing, there's a lot of them. There's a dry line that was just up across, and it was just wrong timing. There's some crazy high cape numbers and deep layers of shear, and it would have enhanced the storm organization to make them into more supercell type storms instead of just being a regular thunderstorm. Next, I'm going to show you what happens when they start popping up and what you should be doing and how you should know if there's tornadoes or not. So on my radar right now, it is 11:21 a.m. on May 20th, 2013, the day of the Moore tornado. So I'm going to show you as it progresses and gets worse into the day. They're going to start forming right by Wichita Falls. That's where they start forming. So maybe because it's one of the more famous tornadoes. So I'll just skip to 1:16 about 2 hours later. In the world of storm chasing, if you want to be a photographer and try to get tornadoes and stuff, you want to jump on those storms as quick. Right now, you would just start going right at them because you know that they're going to be severe. This first one popping up, you know you probably should start going at them. That's how storm chasing works. You just go right after that first one, because usually that first one is a good indicator of a lot more. This is another hour later. You'll see this storm has turned way bigger, for sure. I know it does. It turns way bigger. Yep, see, look, it's probably one of these three. And then at the time of the tornado is 2:55, so I'm going to go to 2:37. And you'll see there'll be a whole line of supercells up and down through Oklahoma City. Very destructive ones. There's probably large hail already in those storms right here. Yeah, look, you can see these ones popping up, and this one has a slight bit of a tail, which is a really good indicator. That's what most of this video is, these indicators for that. Here, I'll zoom in on it. You can easily tell there's a slight tail on it. That usually is a huge indication of rotation, which usually means a tornado. Like, look, there's a slight yellow hook. Now this is the next best. This is the best one. You can barely tell there's any tornado, but you check the velocity map, and you can see the rotation pocket. The red is towards, and the green's away from, so it pulls together, and that means there's two different wind cycles going at the same exact time, right by each other, that are pulling in different directions. That's how you know if there's a tornado or not, or rotation in general. Which obviously is helpful for anybody that's trying to chase one or get away from one. Okay, so now I'm going to jump to 2:55. At the time right when the Moore tornado started. 2:54, that's as close as I can get. It'll pop up right by Oklahoma City. You won't be able to see that. It won't be the greatest zoom in, but you can see it fairly well. So I'm going to show you two different instances though. This kind, which is ideal, completely ideal, just supercells popping up, not in a massive storm system, and then I'll show you the non-ideal, which is way more common, complete. Okay, there it is. You can see that? And there's more right there. So this is the first radar tick when it started. Now you can tell there's a complete actual hook on there now. It's starting to hook. You can see that just forming right there, that shape, that hook shape. That is really important when you're spotting for tornadoes and stuff. And then now I'll show you the velocity radar for it. Base velocity. You'll see there's a huge pocket. Yep, look at that. This is, if I remember right, 90 mile per hour that way, and that one is about 25 the other way. So if you think about that, that's crazy. 90 miles per hour going one way and a bunch going the other way even still. 315, way later. It'll probably be all the way up here now. Whoops. Now there's the pocket up there. And then if I go back to the radar, it's hitting right through Norman right then. This one was so dangerous because it just went straight through the town. It was such a just bad, just going right through the center of the town. You do not want storms like this going through the center of your town. That completely can just destroy it, any town. But it's a pretty big city. But you don't want anything like that. It's just a runoff part of Oklahoma City. It's like their urban area. It's not quite a different town itself. I went down there about 2 years ago and you could just still see it all. You could still see some of the houses destroyed. Or it was probably longer than 2 years, probably like 3 or 4. But you could just see the path damage that was still there. It was horrible. There was just huge marks in the ground. Houses just completely destroyed. It's a very large, destructive tornado. But it was perfect for taking pictures. There were some good pictures taken from it, which is not a bad thing at all. But you do not want to storm chase in conditions like this, especially because it's right in the middle of the city. Those are horrible places to storm chase. You do not want to be caught in a city in traffic when there's a large tornado coming that way. You do not ever. That is one of the #1 rules in storm chasing. Do not go and chase in a city or near a city. It is danger for everybody that's even with it. Okay, so that after all that, let's see. Whoops, it turned it today. Well, that kind of stings. Okay, I'm going to go on to the next thing then, which will be actually showing the tornadoes from that day. As you can tell from this thing, all the tornadoes were red dots, which there was the Moore one right here. There were quite a few down in Texas. There were some ones over in like Colorado, and then there were a bunch dotted right up and down this Missouri, Kansas, Oklahoma line. It's just crazy. And then the wind reports, there's a bunch up all the way through Michigan. I mean, it was a crazy day. There were tornadoes even reported up in Ohio. It was just crazy. There were a lot of tornadoes, and it was only a moderate risk, which I want to see. I don't think I've seen a high risk in a long time. I don't think I ever have myself. Someday we'll probably see one, and it'll be crazy, and you'll know that it's going to be a really bad day, because a bad day like this is just moderate. To the next storm, this one might look familiar too, because it's the one from 2 days ago on Easter. This is the one for April 12th, 2020. This is just a few days ago. Obviously, this one has a larger, moderate scale. We all know what happened in this one, though. There were some crazy tornadoes. I mean, this was 15%. The other one was 10. This is 15% with significant. The damaging wind was 45, which is as high as it can get, except for 60, I guess. I don't remember. I don't think I've ever seen a 60 on any of them. Obviously not on Tornado, because they don't have a 60 for that. But I've never seen high. I've never seen... Oh, there is a 60 for Tornado. Oh my gosh. how, I don't even know. I don't think that's ever been used. I don't even think 45's ever been used for tornado. Oh my gosh. Imagine that though, being 45% for a tornado. That'd be crazy. But back to what I was saying. You obviously would pick somewhere right in the middle heart of this, probably almost where the M is. Right around here, you probably would pick somewhere. So we'll go to the next one, which is the radar from then. Going right back to the radars. So this is from yesterday, 2 days ago. This is that storm that produced multiple tornadoes. So this is a completely different type of storm. This is not a storm you'd want to mess with at all. This is much more dangerous than Slatter, the other one. The supercells that are isolated. You can get away from those a lot easier than you can get away from this kind of thing. This kind of storm right here has a high precipitation, so there's no way you can see the tornado unless you have some sort of radar, which obviously it's hard to use radar, like regular radar, on this kind of storm. These kind of storms you cannot use the regular radar and be efficient. You have to go to the velocity for sure. So I'm going to zoom in on a spot in a second. Okay, so there's a multiple line. There's a large line of embedded cells which are coming up right through here, make them, and then you can see them starting to just retake off. You'll be able to see it in a second where I'm talking about. And then there's the embedded cell. See this? This is an embedded supercell. It's just like the other one over there, but in the other storm. But it was but this is a really high precipitation HPC cell. It's much more dangerous because it's just rain wrapped. And the next dangerous part was keep going. There's two of them right by each other. So this one you can easily tell that there's a hook on it, and you won't be able to see that on other ones, like storms like this. But I'll show you like this, you can for sure tell. There's a very, very, very noticeable debris ball, and there's just a super noticeable hook. But I'm going to show you the velocity, which is even crazier. There's going to be some high force winds going up through here and then up and down in here, which is an easier way to locate these tornadoes. Look at that. There is easily 90 mile per hour one way, and I don't even know. It's gonna be. I can't even tell how much it says. There's the inflow up here and then the outflow out here. It's just completely crazy speed, just pocket of just rotating air mass. That is just a powerful storm. You can just tell. I'm going to check the satellite, because this one I can check my satellite. I'll zoom out a little bit. Just see what it looks like from the radar. It's going to look crazy. Or from right above it. I remember seeing these things live. These embedded cells. And just watching them. And then you could see the tornado warned right around them. It was just crazy. Yeah, look, right around here you could just see the tufts of just the top of that. If you could be right here, you'd get such a beautiful picture of those supercell clouds. I mean, there's no really clear spots in here to get pictures, but you could go up through here, up the meridian, and then you'd be right near that tornado right about here. It's just such a crazy day. We're going to go on to the tornadoes from that day. Now we're on the storm reports page from that day. Now there's 97. Earlier I was on here and it was said 90, so there's been 7 more updated ones. Look how many tornadoes are in that spot. Just look at this long line of tornadoes starting over by Texas and ending in Tennessee. Well, they go up to Carolinas, but they're just multiple. There's a large swath right here. There's multiple swaths right here. There's a few down here. I mean, there's one wind report up in Nebraska. one right in Texas. Now, if I show you the outlook for that day, they almost spot on got it. The SPC. They did a really great job with this storm. They should have probably upped it a little bit, but they did a pretty good job with just doing moderate. Look, that's almost right on. See, you can see it reaches from here to here. And if I go back to that, that's almost right where the tornadoes are. So they did a really great job with that. I'm going to review pretty much what I've said in the video about the storm reports and tornadoes. So what you're looking for on the radar is a hook. And then you're looking for on the velocity radar a pocket of rotation, which is usually green and red right next to each other. And on satellites you're looking for clouds that are flat on the top and have puffs on the top. That's how you usually can spot a supercell. So that's about it. Thank you guys for watching. Subscribe for more. See ya.